Okay. Good afternoon, everybody. My name is Andrew Wright. I'm a safety supervisor here at Cherry Point. I've been working on this project for a couple of years now. We've been exclusively or almost exclusively doing roof repair and roof replacement. So there's a lot of fall protection aspects that we've been doing. So we're going to be going off of the EM 385-1-1 rules, since we do a lot of DoD work and they meet or exceed the OSHA requirements for it. So if you have any questions during it, just feel free to put your hand up or just interject. All right. Okay, so some of the learning objectives of this presentation are going to be to understand the whole process. So it's from planning the work to being able to identify the potential hazards and risk and execution of the actual work in a safe manner. So hopefully by the end, you'll be able to familiarize yourself with some of the fall protection and prevention equipment that we commonly use on our roofing projects here, and which equipment you need to select for specific applications. Also, you should be able to enforce these procedures out in the field, and I'll be sharing some specific instances where I identified some issues, share some lessons learned, and just some tips and tricks I've picked up over here just with all the work we've done over here at Cherry Point. So the most important part of enforcement is speaking up. So that means using your stop work authority. If you see something or suspect something isn't right, everyone has it, so go ahead and use it. You know, for example, if you see somebody not tying off, say something about it. You know, you don't want to be quiet about that. Also, another part of stock work authority for SSHOs and CMs in the field is don't just tell the subs they're doing something wrong and stop work. If you do stop work, provide, you know, an innovative solution to get the job rolling again. You know, that's part of our job out there, is to provide feedback for our guys. But in the end, people make mistakes, forget things, take shortcuts. So this is an effort that we could all participate in. So ECC has fall prevention and protection policies. They can be found on EcoNet. They're pretty in-depth, and there's 3 attachments for fall arrest systems, fall protection training, guardrail and restraint design criteria. If you've never seen the ECC SOPs, you just go to the EcoNet homepage, click on the ESQ organization, safety department, and then health and safety SOPs, and you'll find them there in a list, and you can download them onto your computer if you want. So what's the risk? Falls to a lower level account for approximately 1 in 3 of all workplace fatalities in the construction industry. And roofing, which is what this presentation is focused on, is considered the 4th most dangerous trade according to Fatality Statistics. OSHA continually mentions this as part of their focus during Construction Safety Week, and it remains one of the most cited violations on OSHA sites. So here's the chart that I pulled the info from. This is taken from the National Census of Fatal Occupational Injuries in 2019. So as you can see, it's one of the most dangerous occupations out there due to the routine exposure to heights. So, you know, it just goes back to, it's not just on construction, on the DoD sites too. This includes, you know, residential sites. And how often have you driven by a residential construction project and seen nobody tied off on the roof? So you can see why it's a dangerous occupation. Why it matters. Obviously, if somebody falls, the most important consequence and most devastating is the loss of life or disability or injury. But further down the road, there's immense financial implications. These can be manifested in higher DART ratings, which is days away from work, recordable ratings, total case ratings, and EMR, your experience modification rating, which is higher insurance premiums, or could also affect ECC as a whole for loss of future contract opportunities. A lot of these projects that we get, you're only allowed to bid if you have a low EMR below 1. So if you have a site that has a lot of recordable injuries or anything, it could affect everybody and, you know, affect our bottom line. And then not to mention, you can get OSHA fines and lawsuits. Also, there's the loss of reputation. ECC is a trusted partner of our client, and we have an excellent safety reputation. And one bad incident can undo years of good work. So it's very important. There's direct and indirect consequences. Direct would be, you know, the direct cost of incidents, medical bills. Hey, can you mute whoever's talking? Thank you. So that's medical bills, workers' comp, indirect training, could be loss of time or productivity, stuff like that. So falls can be prevented by planning ahead. Plan ahead to get the job done safely. Provide the right equipment. That's huge. There's so much equipment out there that you could select. So selecting the right equipment is key. And then training. You know, you're only as good as the people actually doing the work. So we got to make sure that from supervisors to subs, everybody's trying to do the job. So we're going to break down each of these. So the first would be the planning phase. So this would be before you start work, you need to develop a fall prevention or protection plans. This is where we implement ECC's company procedures and safety regulations and develop a written plan. It must be site specific and unique to each work location. So it's going to include like a step-by-step breakdown of how to implement controls, identify potential hazards, identify fall clearances, select equipment, and so on. Then we're going to complete the A process. This is where we break down the tasks. Each definable feature of work is broken down into tasks. Each task is then analyzed, and we suggest safe work habits for that. Another important aspect of this is completing a structural analysis of the roof prior by an engineering facility. This answers the question of whether the roof that we're going to go on can actually support a construction load. And the weight rating of the roof can determine which fall protection system. For instance, we had several roofs here on Cherry Point that had a very low construction load rating. So it basically made it so we couldn't put a lot of materials on the roof, and we were limited to what fall protection equipment we could actually use on that roof. And it's also going to be helpful to identify the type of substrate or substructure material used. You know, is it a wood roof? Is it a metal deck? Is it a concrete deck roof? Is it a gypsum deck? They're all going to have slightly different fall protection equipment that's required. So once you've identified the potential hazards, you got a feel for the site, the material, what kind of slope roof it is, any engineering restrictions, then you could select your equipment. This is usually done by the qualified person, and you could verify the training of the individuals. So that selection of competent persons, EM 35 has specific guidelines on what qualifies someone as a fall protection competent person. And then there's the end users. The end users are the guys actually using the equipment on the roof. So put all these into a nice submittal package, give them the sub, and hold them to it. So when we're coming at a fall protection issue on the roof, there's a hierarchy that we use. The first is elimination. So if the hazard is falling, you can alter or remove the task to remove the risk of falling. So you can see from the number one, instead of the guy using a ladder to change the light bulb, he's using a pole. So he's removing the risk of falling. That's typically not an option for roofing because you know the only way to eliminate the risk of roofing is just to not do it, which isn't an option. So the next best thing is passive fall protection. Guardrail systems are most common. These can be installed at the roof perimeter, or there's systems that are mobile. We call them cattle guards. Then the next thing is fall restraint. is fall restraint is a set of equipment that basically prevents the worker's center of mass from reaching the fall edge. So it kind of just prevents them from experiencing a fall to begin with. And then the next best thing is fall arrest systems, which is so you have enough space to actually experience a fall, but you have the right equipment in there to disperse the force, so you're not going to get hurt by, and you're not going to contact something on your way down. And then the least favorable is admin controls, and pretty much the only one in this category is going to be warning line systems. This is just like a reminder barrier that's usually about 6 feet in from the edge that alerts the workers that there is a leading edge or a fall hazard. So if you've done AHAs for the DoD, you are more than likely familiar with this. Just want to take a second to talk about it. Working at heights automatically gives your task a medium risk rating. Why? Because if somebody falls, they could die, which is considered a catastrophic outcome. Even if you reduce the risk to where it's unlikely, you got all the fall protection equipment on there, you've done everything correctly, and you've lowered the probability outcome of the risk to unlikely, it's still a medium risk. So there's always inherent anything, even if everything is executed flawlessly. So that's it for the planning phase. Now let's get into the equipment. And fall protection equipment has the ABCs: anchorages, body support, and connecting devices. There are many options for fall protection equipment, and I'm only going to be going over the ones that we use on our jobs for roofing applications. But there's so many out there, and they constantly develop new stuff. So anchorages and anchor connectors. There's a bunch of kinds for these. Some require installation with fasteners or screws. Some are non-penetrative. Some are permanently installed in the building. Some are temporary. Body support. This is just your harnesses. They've done away with the body belts. So basically, your full body harness is all you're going to see on these sites. And then you got your connecting devices. These are what attaches to the body. These are the yo-yos, the lanyards, lifeline. They usually have shock pads. One thing all your fall protection equipment must have in common is it must be compliant with ANSI ASSE Z359-7 standards. So if you look on all your equipment, it's going to have that stamp on there. That just means that they've been tested and meet or exceed the required force ratings. For example, your anchor points, it can be rated at 5,000 pounds. And also, when you're selecting equipment, you must consider fall clearance, extremely important. So that's the sum of free fall distance, lanyard deceleration distance, harness stretch, worker height, and a safety factor. Fortunately, this information is available on the manual of the fall protection equipment. So it takes out some of the guessing, but calculating fall clearances can get kind of tricky. So you really got to make sure you're on point when you're selecting your equipment. Okay, so we'll start with the anchor points. The one shown in the middle there is sometimes referred to as a butterfly anchor. They're pretty common. They're inexpensive. They require fasteners to be installed in a specific pattern. They can be installed into plywood decking, wood joists. They can be installed into concrete. They can be installed into metal decking. But it's important that you read the manual. And I pulled that little graphic in the middle with the arrows. That's from the manual. It says, do not side load. That's extremely important. That means the force is only designed to be distributed in one direction. So you don't want to install these things backwards because they could pull out if they experience a fall. Another important thing is don't reuse fasteners. And I'm going to say it a million times, just read the product manual for correct installation. For instance, the one shown there in the middle requires, if you're putting it into a metal deck, requires 8 screws on each side in a specific screw pattern. So just look at the manual if you're unsure about anything. Next most common is It's these standing seam clamps. We use these on standing seam metal roofs. We use the Garland roofing system here at Cherry Point. It's a compression clamp. These are good because you don't have to put holes in the roof. You got to install them over a fully seamed panel over a clip. It's good because they don't damage the panels and they're easy to install. Usually you want to install them at the roof ridge to give yourself like the greatest working angle. But again, you don't want to side load them because if you pull too much on perpendicular to the roof ridge, they can roll out. So, the force is only designed to go in one direction with these again. So. Next is cross arm straps, or we call these beam straps. So in the picture, you'll see a beam strap. It's wrapped around a steel beam. This was part of a metal frame that was holding a huge chiller unit up on the roof. It ties into the framing of the building, so it's rated. These are good because they're easy to install, and they could be used in applications where there's nothing else to tie onto except an I-beam, like you were doing a metal deck replacement or something. Next is these non-penetrative anchors. So the one in the picture is called the Guardian Angel. It's a basically it has these plates that you install on it, and it provides enough weight and friction to act as a 5,000-pound anchor point. So in the picture, you can see there's one, and then there's a cable going to another one with a horizontal lifeline. So it's a good option on finished roofs where you don't want to put holes in a roof, But the downside is they're heavy, expensive, and they're kind of complicated to set up and prone to damage. So you're always going to want to check the structural load of the roof to make sure that it can hold something this heavy. A lot of them can be like, between 600 to 1,000 pounds, depending. So. Next, you might see these on some sites are fall carts. So these are ideal for mobile anchor point solutions because you can easily move them around as you're working on the roof edge. They're pretty easy to set up and pretty easy to position. The one picture, you could have 3 guys on a rest and 2 in restraint. Downside is they're heavy as well and they're expensive, but they're good. If you're serious about fall protection, this is a good option, because it does make the work go pretty quickly. All right, next we're getting into the B's. So body support. So full body harnesses. These are great. They allow for mobility, while still supporting the body and dispatching the force in the event of a fall. They do have a max and minimum weight range. It's usually 130 to 310 pounds. So just be mindful of that. They should be snug. Next is going to be a little demonstration video of how to inspect and put on a harness. It's short. If for some reason the audio doesn't work, just say something. It should work though. So.
In this video, we're going to show you how to don a full body harness. Before you can use your harness, you need to do an inspection. When performing an inspection, it's best to hold the harness from the D-ring and shake it a little to get out all the tangles so you can get an organized look. Next, inspect the dorsal D-ring, making sure there aren't any cracks, scrapes, corrosion, or burrs that could damage the webbing. Also make sure to check side hip D-rings and sternal D-rings if it applies. If D-rings are damaged, your harness should be taken out of service. Now it's time to inspect the webbing. Make sure it's free of fraying or tears. Also look to see if you notice any holes or burns from fires or chemicals. If you notice any of these things, the harness needs to be taken out of service. Some harnesses have impact indicators. If these threads are torn or damaged, it's an indication it's been in a fall, and the harness again needs to be taken out of service. If any of your straps have grommets, make sure they're not deformed or show any fraying around their sides. The final part of the inspection is the buckles. If you have a harness with self-locking buckles, make sure they're in good working order. Now you're ready to don the harness. Starting with one shoulder, put the shoulder straps on. Once your shoulder straps are in place, reach behind you between your legs and grab the leg strap. Buckle it and make sure it's secure. Make sure there's nothing in your pockets. During a fall, you wouldn't want something digging into your leg. After securing the leg buckles, make sure that any extra strapping is tied back so it doesn't get in your way while you're working. Your fingers should be able to slide between the strap and your leg with just a little effort, but there shouldn't be enough room to fit a closed fist. Now, buckle your chest strap and make sure it is in the middle of your chest. If it applies to your harness, secure the waist strap. Make sure your chest strap is not positioned too high. In the occurrence of a fall, it could choke you. If it's positioned too low, you could fall out of the harness. Last, make sure the dorsal D-ring is between your shoulder blades in the middle of your back.
Okay. So another aspect of harnesses are trauma straps. These are a requirement on EM 385 jobs, and they're used to relieve orthostatic intolerance or harness hang syndrome when somebody falls and is waiting for rescue. So when suspended by the harness, the legs can cut off circulation to your femoral artery and cause blood to pool in your legs. So this can cause loss of consciousness and actually death. So it's really important that you have prompt rescue. And you really need to be getting people down in less than 15 or 20 minutes to do that. Another important thing, if somebody is hanging up there for a while, when you bring them down, they should stay on the ground and kind of get in a what's called a W recovery position. This is where the worker sits upright on the ground with your back straight and your knees bent. It just kind of lets blood slowly pull back into your legs. Make sure that these are attached to the harness correctly, and that they're in reach of the worker. I've seen some people put them up on their D-rings, and it's like you won't be able to reach that if you fall. As you can see, when you're hanging like that, the harness stretches out, so you need to be able to grab those things and kind of stand up in them. Some newer harnesses actually have these built in as well. Next would be the C of the ABCs for connection devices. These are lanyards. Again, there's many kinds of them, but these ones are pretty common on our sites. Used to attach a harness to an anchor point. They're going to have a built-in force reduction technology, that either in the form of a shock pack on the right or kind of like the scrunchy material that pops open. They have self-closing snap hooks. There's different applications. Some of them have double leads, for scaffolding. A lot of times we'll use these in aerial lifts. Next, there's another short video just on lanyard inspection.
Equipment inspection should be done before each use by the user and inspected by a fall protection competent person annually or as required by the manufacturer. This is a demonstration only and is not considered formal training. First, check the self-locking gate. Once you depress the palm side of the snap hook, this will disengage the lock and the gate should open freely and lock back into place. Now look for any deformities, cracks, rust, or corrosion. Surface rust can be removed with steel wool, but rust pitting can compromise the strength of the connectors and restrict moving parts. These should be taken out of service. Now we can check the shock pack. As you can see on the label, this is designed to reduce arresting force to an average of 900 pounds. You want to make sure none of the webbing is torn out of the shock pack and the stitching is not compromised.
If it had been impacted, there would be webbing coming out of the end of the pack. Most manufacturers use different color webbing inside the pack so it can be identified that it's been impacted. If you notice any of this, the lanyard needs to be taken out of service. Now check any other stitch patterns on the webbing to make sure there is no missing or frayed stitches. Check both sides thoroughly. If there are missing stitches or fraying, take it out of service. Now moving down the webbing, check for fraying, tears, holes, or burns from fires or chemicals. Inspect the entire length of the webbing. If you see any of these things, take it out of service. Inspect the next stitch pattern as you did the first. Finally, check the other snap hook like you did the last one, making sure the lock and gate function and it's in good condition. This concludes the demonstration of a lanyard inspection. Please visit.
Okay. Yeah, so you want to make sure your equipment is good. One thing I can think of, welders are notorious for having, poor fall protection equipment. The sparks and slag come off and can burn holes in their equipment. So make sure that those guys especially are inspecting it. Also, people who do coating or painting, sometimes they use corrosive chemicals that could also damage the nylon webbing. So these are SRLs, or self-retracting lanyards. Typically, they're steel cable or nylon. The nylon ones are used for non-leading edge applications. And by leading edge application, I mean they're successfully tested for horizontal use and falls over steel edge without burrs. So this would be like if you're doing like steel decking or something, you would want to use one of these. They're very common on roofing and scaffolding jobs. Sometimes they're called yo-yos. Many of them have built-in shock absorbers like the one pictured, and they're great because they can arrest a fall in 2 feet, whereas like a typical shock lanyard has a 4-foot deceleration. They have impact indicators, and they must be taken out of service after a fall. And like when they pull, it's kind of like a seatbelt mechanism, and that also acts as like a force absorber. Some pros about these is you don't really have to worry about constantly adjusting, like a lanyard or a rope to adjust for swing fall. You're not going to get tripped up, and you're going to have shorter rest distance. The cons are these things are pricier. Some roofers don't like them because they kind of pull on your back all day. And if you walk too fast or step too quickly, they can lock up on you. We actually had a individual who was stepping over a panel and it locked up and it kind of forced him to the ground and he fell. And he ended up falling off the roof here. He was tied off and everything, so he was okay, but it's something that, can happen. So just might be helpful to incorporate that in an AHA or something if you're using this equipment. Next is vertical lifelines or rope grabs. They include a shock absorber as well. They're good because they're cheap. They could be used for fall arrest or restraint. We typically use them for restraint applications where you don't want the worker to be able to actually reach the roof edge. The cons are, and this is like probably the biggest headache that we deal with when people use these, is you constantly have to adjust them and keep them tight. Because if you don't, there's going to be too much free fall distance or a swing fall hazard. So basically, I have the workers go to the roof edge, and if they're standing at the roof edge, directly in line with their anchor point, that rope should be completely off the ground and, tight. So that means if they did fall, they're not going to go off the roof actually. And these are good. You can get these in they call like fall protection buckets. You can get them at Lowe's, with a harness and a butterfly anchor point for pretty cheap. It's a good, first starter, but we, for the most part, discourage these just because it's constant. It requires constant policing and attention, and you're going to have a long lead rope too that you could slip on or trip onto, and they kind of get in the way. So the SRLs are really a better option. Next is horizontal lifelines. There's a lot of different variations of these. The one pictured is you got two, anchor points in the roof joist, and then like a rope or cable in between. they must be engineered. You can't just like make one yourself with, steel cable and a couple butterflies. They got to be stamped and tested just like anything else. And they're good because they provide like a wide range of mobility, and they do reduce potential swing fall, so you could have a wider range, It's important not to mix or match components with these either. And there's also going to be like some slack too from the actual lifeline deflecting. So you need to take that into consideration when you're calculating your fall clearance. So rescue, this is what to do if somebody does fall. It should be identified in the fall protection plan. So a lot of times self-rescue or having a coworker assist with rescue will be the quickest option. In the picture, you can see that's a rescue ladder. So if somebody were to go over the edge of the roof, you would hook that to an anchor point and you throw that over the edge for them and they could self-rescue. Another good option that we've actually used if somebody falls is a lot of times on these jobs, we're using aerial lifts. You could have someone in an aerial lift pop up there really quickly. And I could tell you that if you could do self-rescue or have an employee rescue somebody who has fallen, it's going to be way better for you than having to call the fire department out there. I mean, obviously call the fire department if there's no options because the clock is ticking. But I could say it would be a major, it'd be more of a major incident if you had to rely on local emergency services because, we're supposed to be professionals out there and have this taken into consideration. And it's supposed to be part of every fall protection plan. So, so that kind of goes down to there's authorized and competent rescuer. A competent rescuer is responsible for anticipating the potential for planned rescue, ensuring that the rescue plan is followed. And authorized rescuer is pretty much the end users who are responsible or authorized to do rescue. So we'll briefly touch on training and different roles. Fall protection program manager shall have a working knowledge of current fall protection regulations, requirements, standards, equipment, and systems. The qualified person shall be trained by a QP trainer in proper inspection, assembly, and use of fall protection equipment and the systems they encounter as worked as a QP. Competent persons, these are competent person for fall protection shall be a minimum of 24 hours, combo of formal classroom and practical applications. I know the EM 385 requires 24-hour fall protection training for their sites, so many of our SSHOs and CMs have this training already. And there's a required 2-hour refresher every year, so you could use this training if you meet that criteria. And then there's the end user training, and those are each worker who might be exposed to fall hazards from heights shall be trained before using fall protection equipment. And that just goes down to anytime there's any type of incident or mishap, the first thing they're going to ask is, was the person trained? So you better have documentation that that person has been trained to use that equipment or to work in that situation. Okay, so this next section is going to get more to the specifics of the fall protection for roofing applications. So as you can see, there are many different types of roof pitches, and they're all going to have like slightly different fall protection considerations. Typically on our sites, we're going to have, flat roofs or gable and hip roofs. A lot of those times those are the metal roofs, but there's many kinds, and a lot of times there's combination roofs too. So pitched roofs, these require a fall rest system installations. So pictured is a garland system, standing seam metal roof with a wood deck. And as you can see, there's an aerial lift in use for doing like the gutter and the roof edge work. So when they started, they were doing the roof demo, and they removed the old shingle roof. So they were working off of butterfly anchor points and replacing the decking. Then these guys came in and they installed the roof. Again, they're going to work off of butterflies installed into the wood deck. And then once they get a couple panels down, they switch to the standing seam metal roof clamps so that they can continually move with the work. Flat roofs, we've done quite a bit of these on Cherry Point. They're less than 412. A flat roof is actually considered anything less than 212. Low slope roofs are considered 212 to 412 because a lot of times they look flat, but they have like a slight pitch to them. Most common type of fall prevention is going to be your guardrail systems. To start, usually they'll put guardrail systems around the perimeter of the whole building. Then they'll do the demo and install. And then when they need to work on the roof edges, they'll take the guardrail system down, install a warning line, and then maybe use one of those fall carts or something similar to do the roof edge work. Steep slope roof, quick definition from the CFR, is a steep roof has a slope greater than 4 12 vertical to horizontal. You can use guardrail systems, but it's pretty uncommon on these slope roofs out here because it's cumbersome to install a bunch of guardrails into the fascia. You can use safety net systems, although I haven't seen them used out here. Typically, they're used on like high-rise buildings. You're mostly going to rely on personal fall arrest systems, so you're going to want to calculate, your fall clearances and make sure you have the right equipment set up for that. And then you have your low slope roofs. It's less than or equal to 412. Guardrail systems can be used on these. Safety net systems can be used. Fall arrest or restraint systems can be used too. You could use a warning line system as well. So the lower slope roofs, the more options you have for equipment. Next, we're kind of going to touch on safe working zones. This is something that we have to police a lot over here. So you'll see a diagram. I pulled this from one of the Anchor Points product manuals. So you can see there's a working angle and then a setback distance. And that corresponds to how much he could walk on the roof and not exceed the safe working angle. So the further back from the edge of the roof the anchor point is installed, the greater the allowable working distances in either direction. So you could reference the manual for this. So I tell our guys to install the anchor point as far back from the roof as possible, and make sure you obviously have a long enough SRL. Because if it's too close and the safe working distance denoted by the X is too great, you're going to expose the worker to swing fall hazards, and you're going to side load that anchor point, which can cause it to fail. So, and if you don't have a handy little chart like the yellow and white one pictured, you could use trig functions as well to figure it out, because in the end it's just a right triangle. So another concept we have to deal with here a lot is leading edge fall protection. So the edge of a floor, roof, or formwork for the floor or the walking surface in which changes location as additional floor, roof, decking, or formwork sections are placed. So a leading edge is an unprotected side and edge during periods when it is not actively under construction. So in the picture, these guys are doing roof canopy installation. So the edge location changes. So it's considered a leading edge. As pictured, there's leading edge rated SRLs. They're cable, so they're designed for horizontal use. And if the guy does fall, they're not going to break under tension. And they're specifically designed for this application. Next is going to be controlled access zones. We refer to these as warning line zones. Can only be used on flat or low slope roofs. They create a boundary to alert the workers. We call it creating a regulated area. Inside this regulated area, if it's installed correctly, you don't need fall protection. Typically, they're going to be 6 feet back from the roof edge on flat roofs. They have to go back to 15 feet back from the roof edge on low slope roofs, or if you're using mechanized equipment. They could be any, almost any material, nylon, rope, chain, whatever. It just has to be rated for 500 pounds. It's got to be flagged every 6 feet. Got to be between 34 and 36 inches high. A lot of times we use these cones that are specifically designed for this, and we use a yellow nylon rope, and we take red duct tape and kind of turn them into like little flags, because they tend to hold up better than the ones pictured. The ones in the picture are like, just like you could buy these from Lowe's or whatever. They're actual roof flagging, but we find the little plastic breaks down and they end up kind of creating a mess. So we made our own. Okay, next is guardrail systems. We're going to be using these on flat or low slope roofs. They have specific force parameters that you need to meet to make them compliant. They're, on the building perimeter. They also create a regulated zone where you don't need fall protection. They require top and mid rails. Top rails 42 inches plus or minus 3 inches, and mid rails is easy, just half the distance between the top and the floor. They have to meet 200-pound force rating in each direction. Sometimes you have to install toe boards on these. So how the regulation reads is toe boards are required on all open sides ends at locations where persons are required or permitted to pass or work under the elevated platform, or were needed to prevent persons and material from falling to the elevated platform. So we've kind of gotten away with this by basically removing and blocking pedestrians from walking in your work area. This kind of goes down to regulating your work area from the ground, so that if you accidentally do drop a tool or something off the roof, there's not going to be anyone in that area because the access is blocked off to that. So in the picture, you can see it's the standard 2x4 guardrail. You install the stackings, into the roof edge, usually like a wood nailer. Another thing you could do is you could install debris netting on these guardrail systems, and they help out a lot when you're demoing the roof to limit, debris, and help, just help housekeeping when you're doing the demo and install. But if you're going to have some severe weather or wind, I recommend you take them down, because they kind of turn into giant sails and they've been known to blow off the roof. So keep that in mind, because we're all working out here in Eastern North Carolina, so you got to have your sites be storm ready. Another way of having fall protection or creating a regulated area is working in parapet walls. These are, the parapet walls are these little perimeter walls on roofs. So any combination of 30 inches or more in height plus a width that equals 48 inches is acceptable. So if your wall is 40 inches tall and 10 inches wide, that's 50 inches, so you'd be good. You just got to go out there with the tape measure and measure it, and if it meets that parameter, then you're good. But if it kind of tapers up and down, you could install a warning line to help regulate the area when the dimensions don't meet that criteria. So we'll get into a little bit of the work here. So specific hazards with deck replacements is you're actually replacing and removing the surface you're walking on. So the picture on the left is replacing a metal canopy decking. So you got to consider the potential swing fall hazards. It's a leading edge situation. So you're going to want to use leading edge rated equipment, which he's using, steel cable lanyard. It becomes time consuming when you have to continually move and reinstall anchor points. So like in the situation on the left, you can't, that's the finished product they're installing, so you can't exactly just put a bunch of holes in the finished product, so you have to work off of the old metal decking. So it does become time consuming, when you have to continually move it. But, at the end of the day, that's what you have to do. That's why a lot of times when you're working on a finished product, it may be wise to invest in a fall court or something that doesn't require putting holes in the roof to install. So on the right is a wood deck replacement, and you may be able to see it's kind of rotted out over there. So that is a tongue and groove planks, and on top is OSB plywood sheeting. So we knew from the planning phase that this roof was leaking. That's why we're putting a new roof on it. So you kind of got to anticipate where you're going to find leaks. So this is the corner and low spot of the roof. So you would expect water to pond there. So that may be where you would expect the water. If there's ponding water, you're going to find rotted wood. So it's not going to be safe to walk on. Other areas, around roof drains are prone to rot, or around any HVAC unit penetrations. So when you're doing your roof demo, you may just want to go ahead and regulate this area and have the guys working there be tied off, just in case you encounter some unanticipated roof rot or something. Another important aspect is how to get on the roof. So typically out here, your two methods are going to be your ladders, your extension ladders, and stair towers. Extension ladders, they got to be at your 4-to-1 ratio, extend 3 feet above the landing, be not longer than 20 feet on 385 jobs. There's a handy app that you could download at the App Store called the NIOSH Ladder Safety Application. Basically, you download it and you put your phone on the ladder, and it tells you if it has the correct angle. It's really easy to use, and it's helpful if you don't want to guess or have to calculate an actual 4-to-1 ratio. The best way to get on the roof, in my opinion, is going to be your stair towers. For jobs that are longer, or it's higher up than 20 feet, these are the way to go. So it's essentially building like a scaffold. The guys building the scaffold, they're going to be using, double lanyards when they're building it under the supervision of a competent person. Once these are up, they got to be inspected daily before use. So there's going to be like a green inspection tag on there too. And it's also a good idea to install plywood or something, so you can have like a door and lock access to it when you're not there, so you're not having people going on your roof. A lot of times it's required in the site plans for these jobs we do anyway. Also, good idea, as you can see on the picture on the right, to post some signage. So mobile elevated work platforms, or we call them aerial lifts, articulating boom lifts, man lifts, scissor lifts, whatever you want to call them. They've been a game changer, as far as construction equipment. Puts the person where the work is. You got to consider, the stability of the ground you're working on. Also, bring the lift down when you're going to traverse and travel around. Biggest hazard with these, is working is going to be like your pinch points. So you don't want to, put yourself in between the equipment and an immovable object. You don't want to travel underneath the boom of these things either. Accidental activation of a lever can move these things, and if you're in the wrong position, it can crush you. Or the hoses do fail, so you don't want to walk underneath them anyway and have them fail underneath on top of you. Like anything else, these equipment must be certified to operate, and they do require fall protection. So when you're tying off to the anchor points inside of these things, you just got to use the lanyard that's short enough to prevent a person from climbing out or getting ejected. The 385 does not allow people to use SRLs in these things. And fall protection is also required in scissor lifts on EM 385 jobs. I know it's not required for OSHA, but the EM 385 does require it in scissor lifts. So next is skylights. These are a major cause of incidents. If you're gonna have a skylight, you're gonna want to regulate around the area. And this kind of goes back to the planning phase. If you see that a roof has skylights, you're gonna want to check them out. Sometimes the skylights are rated for fall protection, and they'll have a sticker on them that signifies that. But if they don't have a sticker, you could just assume that they're not rated, and you got to treat it as an open hole. Or sometimes they'll go on the inside of the building, they'll install like a metal cage to prevent people from falling in. In that case, you could, you wouldn't have to worry about it. But yeah, just assume these are open holes. You know, don't take off the, you know, the lid and then cover them up, you know, unless it's got 3/4 plywood. So if you're gonna be working on these, you're gonna have to be tied off around them too, obviously. Okay, what's wrong with this picture? So these next slides are just some issues that I addressed in the field and just some pictures of corrective actions. So I'll let you all look at the pictures for a second and then I'll tell you what's wrong. So a little bit of background. From the ground, when I came up to the site, it looked like both workers were tied off and using the fall protection correctly. They had their harnesses, they were tied off, you know, with a rope. It looked okay. But when I actually went on the roof and checked out what was going on, it was not the case. So first red flag is one anchor point, one person. So there's two people tied off to one anchor point. That is a no-no. Also, second red flag, there's only 2 screws installed into this. This was a metal deck, so you need 8 screws on each side. So they need about 14 more screws in there. So likely what would have happened is somebody would have fallen, this thing would have ripped right out. And it's not also evident from the picture, but it was installed in the wrong direction too. You know, so the takeaway from this is, you know, perception is not always what's going on. You got to go up there and verify for yourself, you know. Windshield safety doesn't really work with fall protection. You need to get out of the car. You need to get up on the roof and make sure these people are doing it correctly, because they will cut corners. In this case, you know, we had to let this crew go because it was obvious that they were not competent with fall protection. You know, they just kept messing up and they weren't professional. So it was cheaper to, I think it was cheaper to get rid of them than have them, you know, when something happened, then, you know, God forbid. So a little background. This was a one of those non-penetrative anchors, those guardian angel things that I showed you on the previous slides. It was used as an anchor point. It was being used. So again, it looks okay from the ground. You know, it looks even okay, but as I was inspecting it, I could see that one of the pins that was replaced with the screw. So that's also a no. You're not allowed to modify any equipment, you know, at all. So the crew knowingly took a shortcut, and because they lost the pin, they didn't want the downtime associated with red tagging the equipment and replacing it. But if an incident occurs, especially if somebody gets hurt or gets killed, it's going to come out that this unit was not installed per factory spec, and it would be really bad. So especially, you know, if you knew this and you let them continue working on it. So this is a good thing that you need to speak out about. You know, and this wasn't even like it was a bad crew or anything. This was just a common case of complacency. So when I found this, I just red tagged the equipment, and that was it. So these guys are installing standing seam panels about 4 stories up. My thing is, look how much slack he has on that rope. If that guy falls, he's going to fall, you know, a good 5-6 feet before his shock pack busts, and then it starts to decelerate the fall. And you could also fall into the basket or hit that. So what I would have done is I would have had the rope, the anchor point installed at the roof ridge, and had that rope be a lot tighter. And then I probably would have had the crew switch to standing seam beam clamps to be installed on the left-hand side, so that they're not crossing each other's ropes up, and that they're maintaining proper fall angles. So this was a good try, you know. This was on top of a flat roof. This is a metal frame that was holding up a huge chiller unit, you know. It would be a 5,000-pound rated anchor point with a beam strap, but you cannot connect a fall protection rope onto itself. Those snap hooks are only designed to hook onto metal anchor points. They're not designed for this application, you know. So that's just a simple stop and get the right tools out there. use the fall protection equipment as it is intended. So there's a beam strap and it's attached to a pipe boot, a lead pipe boot, which is like a vent. Would this support 5,000 pounds? No. So this was another gotcha moment. So make sure that, this would be a good application to use a fall cart, and the crew didn't want to go get one or didn't want to set up a non-penetrative anchor. So they thought that I wouldn't catch them. So my first question is, how does that harness fit? It's a little loose, right? So one strap on the right, you can see is falling off his shoulder on the left-hand picture. It's not below his shoulder blades, it's way too low. On the picture on the right, you can see that his leg straps are almost down to his knees. They need to be up by the hips. So it's obvious that this harness is way too loose. And it also doesn't have trauma straps, which is required on our jobs too. So it's just making sure the equipment fits the person, because in my opinion, this guy, if he would have fallen, he could have rolled out of his harness, and it doesn't do anybody good if the equipment doesn't fit the user. So this is a hole in the deck. So we were going to demo this roof out, and obviously this roof could not sustain a construction load. That's why it's really important to verify that a roof deck can support the load. We actually knew this coming into it, so the worker was tied off. But this kind of gives you a lesson learned. A lot of times these scopes, when they're written, are written well in advance of the actual work execution, and the sites can change. This is a leaking roof. It continued to leak for, over a year, and the condition worsened. So it's important to check the site prior to start to see if there's any changes in in the site, and to anticipate that. Okay, some takeaways. Planning is just know what you're getting into. All the planning and prep should be completed well in advance. Another thing is make sure everything is in writing and the subs are aware of the expectations and hold them to it. They should have known what they signed up for when they got the RFP and they bid on the job. So you do have means of making them follow your procedures. So when they took the job, they agreed to follow ECC stage procedures. So we need to make sure that they're doing that. If you don't know something, feel free to reach out and ask. Make sure the workers are trained. Be able to spot incompetence if necessary, be able to retrain, or if people aren't working out, they're going to be too much of a risk, just get rid of them. There's too much on the line to take chances. Another issue that we've had is having third tier or sometimes fourth tier subs. Sometimes these guys are subs of subs and they come out to the jobs and, they may not know what they signed up for, but that doesn't excuse them for following the rules. Maybe they're getting paid by the square and they're just trying to hurry up and get it done. That's not going to work on our sites. We need to have the knowledge and foresight to, enforce our policies. Know the requirements for having a competent person on site. It's going to be different for every contract. For instance, some sites require you to have a physical person there at all times. Sometimes you can get away from that by calling the entire base a site. It depends on how it's written. Next is going to be your equipment selection. It can be really complicated, especially if you're working on a roof with a short fall clearance. It's easier if you're working way up in the air because you don't really have to worry too much about fall clearances. But, if you don't know, just ask. The end user should be able to inspect their equipment. If you're using a subcontractor, they should have a written inspection plan where their competent person inspects their equipment. Know the difference between restraint and arrest applications, and read the manual. I can't stress enough because that's gonna trump pretty much everything. If manufacturer specification says that, then that's what you do. Last is verify, fight complacency and don't get complacent yourself. More than likely a sub will try to cut corners at some point and put production over safety. So, don't assume that just because they've been working safe every day and they're a good crew that they're going to continue to do so. So, one safety incident can have can derail an entire productive and profitable project and affect many other future projects. So the shortcuts are just not worth the risk. So if you see something, speak up. That's it. Any comments or anything? Questions?
Very comprehensive, thank you.
Okay. Hopefully everybody's still on.
Natalie, do you want to talk?
Sure. Just real quick. Thanks, Pete. Thanks, Andrew. I just sent out a link to the quiz, and if you click on that link, it should take you directly to the quiz. If you pass that quiz, it'll count towards your attendance today. So go ahead and do that now. It's only 13 questions, true or false. And let me know if you have any issues having access or if I might have just missed over you. So thank you.
Thanks, everybody. Appreciate it.
Yeah, thank you, Andrew. Great job.
Thanks.
Good job, Andrew.